This presentation provides an overview of two leading climate science information portals available for South African planners and decision makers. These sites provide information on climate history and projected climate change, looking at climate variables such as temperature and precipitation. The following websites are included in the presentation: the Climate Information Portal or CIP tool, and the Climate Change Knowledge Portal. Additional information on these portals can be found in the Let's Respond Toolkit, tool number 6, which can be downloaded from the Let's Respond Toolkit website. The University of Cape Town's Climate Science Analysis Group, or CSAG, has developed the web-based Climate Information Portal tool. The tool was developed to provide easy and effective access to historical and future climate projections. As a start, users can view observed or historical climate data. This historical data allows users to view and compare the variability in rainfall, extremes in seasons, and dry and wet years over a period of time. The tool also allows you to access future climate projections using different dynamic global climate models. Before we get into the details of the Climate Science Analysis Group website, it is useful to define two key climate change modeling concepts. These are percentiles and representative concentration pathways, or RCPs. Let's first look at percentiles. A range of mathematical models have been developed by climate scientists to try and accommodate the complexity of climate science. These models show slightly different results depending on the assumptions and the calculations used in the models. So to get an overall picture, climate science looks at a range of these models. The results of these modeling exercises are then grouped into ranges called percentiles. For example, if you're looking at the potential increase in temperature in a particular area, and half of the model prediction results lie above a 2 degrees increase, and half are below a 2 degrees increase, then the 2 degrees increase is called the median or 50th percentile. The data that lies above the 90th percentile or below the 10th percentile are usually regarded as outliers and are ignored. For basic modeling purposes, the median is usually the simplest guide, with the range between the 90th and the 10th percentiles indicative of the agreement or lack of agreement between the various models. The second climate modeling concept is the representative concentration pathways concept, or RCPs. RCPs are future scenarios or pathways for the world in terms of climate change. Scientists have developed 4 RCPs depending on the global community's effectiveness at reducing greenhouse gases. The 4 scenarios are grouped according to the amount of carbon dioxide equivalent that are predicted to be in the atmosphere by year 2100, measured in parts per million, or ppm. Bear in mind that the global concentration of carbon dioxide equivalent was less than 300 ppm before the Industrial Revolution, and we have recently passed the 400 ppm mark. The graphs on the right of the slide show emissions of the main greenhouse gases across the different RCPs. The 4 RCPs that have been developed are RCP 8.5, which is the least optimistic pathway and predicts a future with more than 1,370 ppm carbon dioxide equivalent by year 2100. This pathway is shown in the blue on the graph on the right. RCP 6, which will result in 850 ppm carbon dioxide equivalent by year 2100. This pathway is shown in black on the graph. RCP 4.5, which will result in 650 ppm carbon dioxide equivalent by year 2100. This pathway is shown in the red on the graphs. RCP 2.6, the most optimistic, which will result in 490 ppm carbon dioxide equivalent before year 2100, and then decline by year 2100. This pathway is shown in green on the graphs. It's obvious that the more carbon dioxide equivalent in the atmosphere, the more severe the impacts of climate change will be. Now that we're familiar with some of the key concepts on climate change modeling, let's go through an example of viewing and understanding historical data from the CSAC website. You can start by opening your browser and navigating to URL cip.csac.uct.ac.za. This is what the website's landing page looks like. The website currently does not require any login detail to access the site. So once you land on the page, you can go directly to the Datasets section of the website by clicking on the Datasets tab in the navigation bar at the top. This page shows you two different sets of coupled model intercomparisons, project data or CMIP data. CMIP3 and CMIP5. The bottom set of data, CMIP5, has more information as it includes country-specific meteorological data, not just global data. You can use the CMIP5 dataset by clicking the highlighted Africa Merged Stations CMIP5 link. Clicking on the link will bring up a map showing the whole of Africa. You can zoom into South Africa using the scroll wheel on your mouse. After you've zoomed into South Africa, you'll be able to see that stations have data available, or see which ones have data that's available. This is indicated by the small blue location pins. If your town does not have a blue marker, you would have to use the marker closest to your town. For the purpose of this presentation, we're going to look at data from Kroonstad. By clicking on the blue marker at Kroonstad, a pop-up window showing different options displays above the pin. From here, click on the highlighted Historical Climate Records. This is the highlighted link that's showing on the pop-up window. This next window shows you a summary of the available historical climate data for Kroonstad. A drop-down menu bar at the top of the graph allows you to select different variables depending on the type of data you're wanting to view, such as monthly rainfall, average maximum temperature, or mean dry spells. You can also select the dates for the period you want to look at. You can download your selected data as well as save it remotely as an Excel CSV file. Closing the pop-up box will take you back to the original menu. This time, let's look at the historical average seasonality by selecting the highlighted historical average seasonality link, which is highlighted. A window showing the previous data summarized over months will be displayed. This graph is useful in clearly showing seasonal fluctuations throughout the year cycle. It's possible to disable or select what you want to be displayed on the graph. You can do this by clicking on the menu item. The graph also allows you to view data points by scrolling over them. Similar to the data we looked at in the previous slides, you can again download this as a graph or by clicking on the download button on the top right-hand side of the graph. If you close this pop-up, you'll go back to the original menu. This time, let's look at future climate projections by selecting the highlighted Future Climate Projections link. When you click this, a graph showing the range of results from 10 different models displays on the screen. The bottom axis shows the months of the year, and the vertical axis shows the change in total monthly rainfall. The gray lines show the projected change for each model. The solid bars represent the range between the middle 80% of the projected change, excluding the upper and lower 10%. The easiest way to interpret the graph is to imagine a halfway line between the top of the blue bar and the bottom of the red bar. This line would be close to your 50th percentile. Looking at this graph, in January, the line would start at around 16 millimeters, while in February, it would be closer to 8 millimeters. In March, the 50th percentile line would drop to around minus 10 millimeters, and so on across the different months. You will also note that the drop-down menu says Total Monthly Rainfall RCP is 8.5. You'll remember that RCP 8.5 was the least optimistic future scenario, with more than 1,370 ppm carbon dioxide equivalents by year 2100. Another variable you can change in the time series In this particular graph, the time period is set for 2040 to 2060. You can change this period by moving the slider on the graph. So this particular graph says that with particular severe climate change during the 2040 to 2060 period, Kroonstad will see increases in summer rains, and increases will be in the region of 10 to 20 millimeters, while there will be less rain in the region of 10 millimeters from March to October. If you change the period to 2010 to 2030, which is the short to medium term, the graph shows that the change in winter will be less severe, with an overall increase in rain over the year. Bear in mind that we are currently only looking at the results of RCP 8.5. You can change the model to RCP 4.5 with the drop-down menu. RCP 4.5 is the relatively optimistic pathway with atmospheric carbon at 650 ppm by year 2100. For RCP 4.5, over the 2010 to 2030 period, we can expect an overall increase in rain over the year, except in the months of February, May, and June. The graph doesn't only show rainfall projections, it also has a number of temperature-related results. If we go ahead and select average maximum temperature for RCP 4.5 over the 2010 to 2030 period, you can see over which months you will have the most severe increases in maximum temperatures. If we look further into the future, say in 2050 to 2070 period, then you can see the temperature range increases in between the 1.5 to 2.5 degrees increases. As with the historic data we looked at earlier, you can download everything as an Excel CSV file. And the graphs, you can download these as images. The CSAC websites can be very useful in giving you a basic understanding of potential climate change impacts in your area. When you are using this website for the first time and start looking at the data for your area, it's probably a good idea to just use the RCP 4.5 models and the 50th percentile. Once you're more familiar with the data and understand what it means, you can start exploring the implications for different models and percentiles. Another useful website resource is the World Bank Climate Change Knowledge Portal. You can access this on sdwebbx.worldbank.org/climateportal. Following the link navigates you to the front page of the portal. You can select Africa and then South Africa from the grey map displayed in the top right corner of the page. The modeling information on this website is at a country level. However, the site does include more sector-specific information under the Impacts and Vulnerabilities tab, displaying on the navigation bar at the top. There are also some very useful links to other resources at the bottom of the page under the Adaptation Tools section. For example, you can see links to adaptation learning mechanisms, climate adaptation knowledge exchange, as well as We Adapt. Many of these resources are updated regularly, particularly as more information becomes available. These sites provide a significant amount of information and resources that can help practitioners understand the key risks of climate change in their area and begin the process of responding to climate change.